Hello, everyone. Welcome to Wind Down Friday. Today, our special guest is Ray Ridley, the CEO of Ridley Engineering. Hi, Ridley. Welcome aboard. How is it going?
Good morning. Everything's great. Thank you. Good to be here.
Thanks a lot for being here. Where are you located, Ray? Which part of
We
US?
are we are on the west coast of the US. We're in California. We're just an hour north of Los Angeles.
North Los Angeles. Nice.
Yeah.
Okay, good. So let's start. Ray, I have prepared a couple of topics to share with you. So our community would like to know more about you, your activity. So your career spans decades of practical, hands-on work in power electronics. This wonderful science. So from
Mm.
consulting to developing specialized tools like frequency response analyzer, software design, and so on. So tell us more. Can you tell us how it all started? What first inspired your journey into this science, this field?
Well, I always knew I was going to be some kind of engineer because even as a kid, I would play with Legos and Meccano sets, and I was always building things and taking things apart, and became a young entrepreneur at the age of 10, I think, when I did a bicycle repair service for my friends at a very young age. So I just like making things with my hands. And when I went to university, I went to Boston University and did electronics, electrical engineering there. And my transition into power electronics was doing a senior project, which was to build a switching power supply. This was in very early 1980s. It was an LLC converter, which was way ahead of its time. And my advisor, who didn't know any better, just set me loose in the lab, working off the AC line to generate 6,000 volts AC on the output. And I just spent many, many months in the lab, winding transformers, blowing things up, measuring things, and eventually getting a successful project going. And then when I went into industry and for interviews, I thought I wanted to be a digital engineer. So I went into the digital control, the logic side of things. And then I found that as soon as they realized I had done a power electronics project in school,
Mhm.
they shunted me over to the power department because they were so desperate. This was the early 1980s for people with any switching power supply design experience because it was a very new field at the time. So that's how I got my first start into power supply design in a computer company in Massachusetts, and never really looked back since then. As I always tell people, when they come to our workshop, once you've done one power supply design, that's your career forever. You will never escape power electronics. And the good side of that, of course, is such a solid field. It just grows and grows every year. And the skills you learn today, you will need them 30, 40 years from now. It doesn't change at the same time as an amazing changes do come into our field. The basic skills stay the same.
Thank you. Thank you, Ray. Very nice. So, your consulting, your company, Ridley Engineering, is known globally for training, consulting, powerful tools for real-world design, as also I mentioned at the beginning. So you have worked with countless engineers and companies around the planet. So tell us, is there a particular moment, a particularly memorable moment that stands out in your life, in your consulting work?
Well, I think I have a lot of consulting stories of going into companies and helping people with their projects. They're fairly. Always when I go in, sometimes it's hard for young students to understand. Is nobody wants me to go in to do analysis for them. They want to sit me in front of the hardware and fix their hardware. And you know that's what I do well. I can look at a power supply, I can look at a SMAC, and I can see things, right away. I know things that are going wrong, things that are going right, and I can help in that front. So that's always fun. And and the teaching side, I think my big realization on that was 25 years ago, I had a feeling that people wanted not theory so
Mm,
much, but they
mm,
needed to get on the bench. They
mm.
needed to make things because that's where you really learn. And that's where I really learned in my first ever project by building, iterating, sometimes blowing things up. That
Yep.
cements it in your mind. So we started doing our workshops with hands-on circuits. And we didn't realize how successful it was going to be. We had people wind magnetics, which nobody else does, in the middle of the workshop. And even though it's a fairly simple task, it's something that's completely missing from the education. So that just brought home to me the importance of actually building things. You've got to build. You can't just run simulations all day and do analysis all day. So, I'm just a big believer in the hardware in power electronics. So that's so important.
Nice, thank you. So, Ray, your workshops are highly respected across the industry. So, what's the philosophy? What's the core philosophy behind the way you teach, you are teaching, and why do you believe the hands-on approach is so critical for engineers in today's engineers?
Well, they let's talk about the attendees. The attendees usually are new hires at companies or people that have been there maybe 5, 10 years, and they realize that they haven't had the formal training in power electronics. And when they look at the formal training, you mentioned the books behind me here, they can go read through literally thousands of books on power electronics, but they emerge from the other side of that none the wiser. And by actually building in the lab, actually making things,
Yep.
that's where we give them theory in the morning, but people can only absorb maybe 2 ideas a day,
Hmm.
concepts idea a
Hmm.
day, and equations perhaps. But then when they see it in the lab and they see the pictures, they see the wave shapes, they see the curves, that's when they really understand what it is that they're doing. And that part is so important to them.
Nice. So, as the philosophy of Wind Down Friday, I ask usually beyond the job, beyond consulting. That means my next question is which are your hobbies? So, when you are not working, do you have any personal hobbies that complement your professional lives, perhaps offering a different also perspective or approach to problem solving? Tell us more about your life.
It's an interesting question because we often ask our course attendees what their fun occupations are. If you ask them what they do, they tell you about their job. But if you ask them, no, what do you do for fun? That they really struggle with the concept. What is that I do for fun? And they don't really know. It's hard to answer. And you have to dig a little deeper with engineers because they're always thinking about their circuits. But as I think when you're doing your hobbies, you're doing the things that clear your mind. That's actually when you have the good ideas for innovation in your job. So I have many, and they change all the time. Originally, I came to the US on a running scholarship, so I was a runner for many years.
Oh,
I was in track and field,
how
and
many kilometers? How many kilometers?
I did the 400 meters originally, and then I moved to the 800 meters and the 400-meter hurdles. So probably the toughest events of all. And when I'm in front of an audience of thousands of engineers, nothing compares to the stress of being on the track. So that was a good preparation. I don't run anymore, just my body kind of said, okay, it's enough of that. We've done enough miles. So I play tennis quite a bit, taking that up recently. I go sailing, which is an interesting exercise in wind energy management, and so on. Having a sailboat that has to maintain itself over several days at sea is quite interesting. And just the sheer power of the wind when you got a big sail up there, it's like, of course I'm out there doing the energy calculations. It's, I got a 40 horsepower motor here and my sails are making me go faster than the motor does. So that's about 50 kilowatts coming out of the sail as we estimate. It's quite a fun thing to do. So I also play some instruments, a little bit of piano, a little bit of guitar, which
Wow.
helps me think. Again, I didn't start that until I was about 40 years old. And we find lots of engineers in our course that are actually very good guitarists or musicians. It's two fields that go very well together, but lots of times I think the engineer thinks they can't be musical at the same time, but they do actually complement themselves quite well. So that
Good.
those things keep me pretty entertained. Just finding the time to squeeze it all in is the challenge, really.
So, talking tennis, which is your favorite tennis player? Because now there is an Italian guy that is doing very good, Sinner.
Well, he just lost though, didn't he, to Alcaraz? I'm always rooting for the underdog. I like Taylor Fritz, who's just always on the verge of making it, and Tiafo, if you
Mhm.
know him. And then there's a big guy out of Michigan who's about 6'10". He's got like 150-mile-an-hour serve. He's fun to watch because he's so big and he can be so gentle with the ball as well. So I just enjoy all of them. But
Good.
half the time, if tennis is on, I just want to go play. I don't want to read about it. I don't want to watch it. I want to go do it myself. It's time. It's more fun
Thank
that
you.
way.
Thank you. So,
Pleasure.
Ray, well, we are in conclusion. My last one, my last one question. Looking back at your career, looking forward for the future. So, what advice, suggestion would you like to give to next aspiring engineers entering this field? I mean, power electronics industry. What mindset should the next generation of engineers bring to thrive into this space. So what is your advice?
Well, the first main question I get asked from students is, should I even go into this field? Is it a field that has legs that will be here in the long run? Because so many technical fields they disappear.
Right.
Um, but that mostly applies to programmers and so on. Digital, if they it changes so fast that what they learn one day, a language they learn today, they're not going to use it tomorrow or next year. Everything changes so fast. But 10 years ago, I had difficulty answering that question because I wasn't sure, because this
Mhm.
field was getting ready to go through a dramatic change and it was kind of aging as a field and things weren't moving that fast. But then,
Mhm.
of course, we had alternate energy and everything else came in, huge funding for that. Most of our course attenders now are actually very young, which is a huge change because they
Mhm.
all used to be in their 50s and 60s and up coming in. So yeah, it's a good field to go into. Um, you're not going to be rich as in any engineering field, but you will always be needed.
Mhm.
Everybody needs the power electronics engineer. But to students, I mean, it's the same theme again. When you're in college, build something. I don't care how you do it. You've got to build things. You've got to get in the lab. You've got to make things because you realize that all that wonderful theory out there, it falls apart when you're switching power. And when you go out for interviews from college, nobody cares how much analysis you did. Nobody cares that you can give them a triple integral and solve it. They want to talk about the hardware that you built and they want you to be passionate about it. They say, hey, I built this circuit, it was blowing up. I solved it by doing this and describe what it is. And the whole interview will be about the circuit that you built, which you should be passionate about. And just the relentless pursuing of a problem on a circuit and solving it, you know, try to get into that as soon as you possibly can. Build difficult things, make them and solve the problems. So back,
Good.
back to the same thing, hardware, hardware, hardware to verify the analysis that you did perhaps, but you can't ship a simulation. People want hardware. So just get that hands-on experience. And you can do it on a budget. When I was in university, I had a vacuum tube scope.
Mm.
I had a vacuum tube signal generator
Mhm.
because the universities don't have a lot of budget. And
Yes.
I would go to Radio Shack, which is no longer around, and buy discrete transistors and wires and scrape things together. So you don't need a huge budget to make things. And so don't make that the excuse, because it's so much more accessible these days. But just build and know your subject so well. Be an expert at what you're doing.
Thank you. Very nice. Thank you, Ray. So thanks a lot for this opportunity. Thanks a lot for giving me the honor to talk with you. It's been super. I wish you a great weekend. Stay in touch. Stay in touch with your next activities. So keep me posted. And so I wish you all the best. Thank you, Ray. Have a good day.
Thanks so much, and thanks for the opportunity to talk to you. Bye bye.
Bye.